Okay, this is going to be the video that's the physics application worksheet. All right, so you're going to work on you're going to watch the video and then you're going to go to Moodle and work the physics application worksheet. Okay, let me pull up my PowerPoint. All right. If I told you, for instance, before we kind of start, what if I told you that I was going to take a trip to New Orleans and from my house, it's about 210 miles to New Orleans. And I told you it takes me 3 hours to get there. And I say, so how fast was I driving? Okay, so think about it. If it's 210 miles and it took me 3 hours, how fast was I going? Now, most of you would tell me that you were going 70 miles, that I was going 70 miles an hour. And I would agree. But does that mean I'm going 70 miles an hour at every second that I'm on the trip? That means that's kind of my average velocity. My average speed was 70 miles an hour. So let's talk about average speed first, and then we're going to switch and talk about instantaneous speed or instantaneous velocity. All right, let me kind of show you a similar problem. All right, do we understand that the way that you got that average velocity a minute ago was you took the change in position? So you looked at where I was at my house and then where I was when I got to New Orleans, and the change in my position was 210 miles. Okay. And then the change in my time. So if I started at 9 in the morning and got there at noon, it took me 3 hours. So that's where you got that 70 miles an hour. So if you want to do average velocity, you take the change in your position, the change in your distance, how the distance that you traveled divided by the time it took. So look at this one. A ball is dropped from a height of 100 feet. So I'm standing on a cliff and I let go of the ball and it falls 100 feet and hits the ground. The height of the ball, so where the ball is above the ground, is going to be called S, and my time, I'm going to call it T. And so this formula right here will give you the height of the ball above the Earth's surface at any time. So if you want to know where the ball was after 1 second, you plug in 1. If you want to know where the ball was after 2 seconds, you plug in 2. Okay? So this one says find the average velocity between 1 second and 2 seconds. All right. So does everybody understand? I'm going to find my position at 1 and find my position at 2, and I'm going to subtract them because it's the change in them. So I would give you this formula on a test. Okay. You wouldn't have to come up with it. You just have to remember that's measuring a distance. Okay. From any object and the Earth's surface, like how far between the two. So I want to know where I was after 2 seconds. So I plugged a 2 in there. So 2 squared is 4 times that negative 16 would give me a negative 64 plus 100 would be 36. So 2 seconds after I dropped the ball, I'm 36 feet above the ground. Now, what was I 1 second after I dropped the ball? Well, I plugged in a 1 and got 84 feet. You say, well, how come I was higher? Remember, it's falling. So it's the distance is getting smaller the longer my time goes. So, and then 2 seconds minus 1 second is a 1. So up here, I've got a negative 48, and down here, I've got a 1. And so I get a negative 48. Now, you panic and you go, why is it negative? Okay. Velocity is speed with direction. So the ball is going 48 feet per second, but where is it going? It's going down. So that's why it's negative. So another way of looking at it is this. Speed is the absolute value of velocity. Okay. So sometimes when you're taking a test for me or a standardized test, you need to understand, are they asking me for speed or velocity? I said, find the velocity. If I had said find the average speed, then it would have been a positive 48 feet per second. I mean, think about it. In your car, you don't have a velocityometer, you have a speedometer. You can be going 30 miles an hour forward or 30 miles an hour backwards, okay? But it's just 30 miles an hour on your speedometer. Okay. Then this one says, well, what's the average velocity between 1 and 1/10 seconds? Let's narrow the gap. Well, again, I would just plug 1 1/10 in my position formula, which I did, and I got 80.84. And then I plugged 1 in my formula again and still got my 84. And then 1 1/10 minus 1 is 1/10. So 1/10 of a second has passed. And so I went 33 6/10 feet. All right, I went 300, I went 3.36 feet. But when I divided by that 1/10, I got a negative 33 6/10 feet per second. Again, why is it negative? Because it's going down. Now, why is it faster up here than it is down here? Because this is going further down, remember, it's speeding up. Well, what if my goal was not to find average velocity? What if I wanted to find exactly how fast the ball was going at exactly 1 second? So do you understand that I would just narrow the time, like from 2 to 1 to 1 1/10 in 1, or maybe 1.01 in 1, or 1.001 in 1. So if that change in time starts shrinking, my average velocity gets closer and closer to being my instantaneous velocity. All right. So that's why this is going to be true. All right. Now I kind of wrote it in a little bit different form. Remember, average velocity was this. But as this bottom number gets smaller and smaller, as my gap in time shrinks, as it gets closer to 0. Now, what happens, and remember, all I did here, this formula right here should look familiar to you, only you're used to seeing F's and X, not S and T's. Do you see that this is your definition of a derivative? So when you take the derivative of your position function, that's going to give you velocity. So when I give you the S function, to get the velocity function, you just take the derivative. Now, here's the way a problem is going to be worded. We're going to kind of go work every piece. A diver jumps from a diving board that's 32 feet above the pool. So I've got this really high diving board above the pool. It's 32 feet. And the diver comes off the board with an initial velocity of 16 feet per second. Okay, cool. Now, I ask you several questions. I ask you, when did the diver reach his highest point? I'm asking you, what was that highest point? What's the maximum height above the ground? I'm asking you, and I've had a grammatical error that I meant to put back. When did the diver hit the water? Did it take him 5 seconds to hit the water, 20 seconds, half a second? What are we talking? And then I want to know, what was the diver's velocity when he hit the water at impact? And I say given, and I would give you this formula. So you don't have to come up with this formula by yourself. Now, what I want you to understand is S is a distance. So is when you plug a time in, it'll tell you where the object is at that time. So if you plug a 1 in for T, it's going to tell you how far above the earth that object was after 1 second. If you plug in a 2.5, it's going to tell you where that object was 2.5 seconds after you threw it. All right, so let's kind of go look, and we're going to work these kind of one by one. Now, I went ahead and rewrote the formula. I would give you that formula. So you'd have that. It said, when did the diver reach his highest point? Now, when is a time question. So you're going to end up with a time. Now, I want you to think about it. If I jump, or if I take a ball and throw it, or if I shoot a bullet, I mean, when something goes up, think about what happens. It goes up, 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 up. What does it do for a fraction of a second when it's at its highest point? It stops. So when it stopped, it's at its highest point. Well, what do you know for sure when something is stopped? It's not moving, so what's the velocity? You know the velocity must be 0. So anytime they ask you, when did the object reach its highest point, the way you work that is you set velocity equal to 0. Now, back on the other slide, how did I tell you to find velocity? Velocity is the derivative of position. So I'm going to go up here and take the derivative. Well, that 2 would come down. So 16 times that 2, that's why I get a negative 32, and that power goes down to 1. And then remember, I don't touch numbers in front, and the derivative of t is just 1, so I just get 16, and then the derivative of 32 is 0. So here is my velocity formula. So when I want to know when the ball reached its highest point, when the bullet reached its highest point, when the diver reached its highest point, I just find my velocity formula and I set it equal to 0. So I took that formula and set it equal to 0. So I subtracted 16 from both sides, and then I divided both sides by -32. And the negative divided by negative is a positive, and 16 divided by 32 is a half. So a half a second, 0.5. All right. So he didn't jump. He wasn't in the air real long going up. Then I ask you, what was that maximum height? Now, for height questions, you've got to use your position formula. Remember what I told you before. This position will tell you any height that you're at as long as you know what time to plug in. Well, I know how long it took now to get to the maximum height. It took half a second. So I just took that half and plugged in to my position, and I got 36 feet. So you want to know where he was after 4 seconds? Plug in 4. All right. So, except we'll talk about why in a minute. That can't exactly work on this one. All right. Now, did he really jump 36? I didn't ask you how far he jumped. I said, what was his maximum height? Because I'm thinking, he jumped 36 feet? That's not humanly possible. Well, if you go back and read the original problem, remember what I told you? I told you the diver started out, the board was 32 feet above the pool. Now, remember, the pool's on the Earth's surface. So if his highest point, he was 36 feet above the pool, he really only jumped how many feet? See, you really only jumped 4 feet. But you got to pay attention to the questions. Did I ask you how far did he jump? Or did I ask you how high did he go? I asked you for the maximum height. That's why the answer is 36 feet. But, he didn't jump 36 feet. Okay? Now, this next question asks you, when did the diver hit the water? So we understand something goes up, 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 up. For a fraction of a second, it stops. Then it starts coming down. Now think about what happens when it's coming down. It's going faster and faster and faster and faster. Then boom, it hits the ground. So when it hits the ground, the velocity is not 0. The velocity may be the fastest it's been going the whole time. What's 0 is S. So if it asks you when did the object hit the ground, you set your S position function equal to 0. Think about why. Remember what I told you. This S measures how far between any object and the Earth at any time. Well, if you're on the Earth, your distance from the Earth would be 0. So I set this formula right here equal to 0. That's a quadratic equation. So I've got to factor it. Now, this one factors all pretty for ease for video. Most of the time on your worksheet, they're not going to factor. So if they don't factor, you've got to use the quadratic formula. And from the last test, some of us do not know the quadratic formula. So go Google it and memorize it. Okay? Now, I'll look to see if I can pull some numbers out, even if I have to use the quadratic formula, because I'd rather use smaller numbers than bigger numbers on that quadratic formula. Okay? So I noticed that 16 goes into all 3 of those numbers. But instead of pulling out 16, I pulled out a -16. You don't have to pull out a -16. You can pull out a +16. But most of you like your squared term to be positive, so that's why I pulled out a -16. Well, remember, I need this to be plus. So a negative times a negative would give me a positive. So that's how I knew that's going to be a -1 right there. And the same thing, I need that to be a plus, so that's got to be a minus. So see, that'd be a -16t squared. That'd be a +16t and a +32. Then this factors. If this didn't factor, I'd go use the quadratic formula. So it factors into t minus 2 and t plus 1. So I've got to apply together to give 0. One of those must be 0. Or t minus 2 is 0, or t plus 1 is 0. Well, -16 is not ever going to be 0, so that one's not possible. I add 2 to both sides, so t might be 2 seconds. I solve this one, and I get a -1 second. Now, can there really be a negative time? No, so that one's not going to work. So this is the only answer that works. It took it 2 seconds to hit the ground because the pool's on the ground. Well, then it says, what was the diver's velocity? Well, if I want to find the diver's velocity, I plug time into the velocity formula. I just need to know how long it took. Well, I found out here it took it 2 seconds. So I plugged 2 in that formula and got a negative 48 feet per second. All right, so let's make sure we're clear. On the worksheet, it's going to ask you a lot of these same questions. It's going to ask you, when did something reach its highest point? What was that high point? It's going to ask you, when did the object hit the ground? It's going to say, so how fast was it going when it hit the ground? Anytime it asks you, when did the object reach its highest point, you have to set velocity equal to 0. Well, how do you find velocity? You take the derivative of your position. When it asks you, when did the object hit the ground, then you set S equal to 0. And you're going to have to factor to do that. Now, when it asks you what was the velocity, you've got to use your velocity formula and plug in a time. When it asks you what a height was, you got to take your position and plug in a time. Okay? Now, think about if you're in your car and you want to change your velocity. All right, so you want the change in velocity with respect to time. What do you do to change your velocity? Now, most of you are going to say you push the gas. And that's true, but what's the real word for that gas? Isn't that called your accelerator? So acceleration is the change in velocity with respect to time. Now, you can get average acceleration or instantaneous acceleration. Well, how do you get instantaneous acceleration? Well, remember, velocity was the change in position with respect to time. In other words, it was the derivative of S. Well, acceleration is the change in velocity, with respect to time. So that means it's going to be the derivative of velocity. So when you take your position formula and you take one derivative, you're going to get velocity. If you take the derivative 2 times, in other words, if you take the derivative of velocity, you're going to get acceleration. So look what this next little slide just kind of says real quick. Acceleration is the derivative of velocity. So notice what happens. I'm going to give you a position function. So to get velocity, you take the derivative. And when you do, you get a new function. Well, what happens if you take the derivative of your new function? You get acceleration. And so the derivative of a negative 32t is just a negative 32, and the derivative of a constant is 0. Now, why is that just a number? Because after you shoot it or throw it or jump or whatever, the only thing acting on it is gravity, and this is acceleration due to gravity. So you are going to work a worksheet that's got problems very similar to the questions on this page. So when did the object reach its highest point? You're going to set velocity equal to 0. When did the object hit the water or hit the ground? You're going to set S equal to 0. So you try that worksheet and let me know if you have any trouble. Okay? All right, so let's kind of stop this sharing. And you try that worksheet and let me know if you have any trouble when you come into class next week.